Hello, everyone. Thank you for joining us today. My name is Yasmina Greco. I'm with O'Reilly Media, and I will be your host for today's webcast. We would like to begin today's webcast by saying a very big thank you to Limelight Networks for sponsoring today's event, and we'd like to let you all know Limelight Networks is a global leader in digital content delivery, empowering customers to better engage with their digital audiences by enabling them to manage and deliver their stories on any device anywhere in the world. Limelight's award-winning Orchestrate platform includes an integrated suite of content delivery technology and services that helps organizations deliver exceptional multi-screen experiences, improve brand awareness, drive revenue, and enhance customer relationships, all while reducing costs. Thank you again, Limelight. Joining us from Limelight today is Steve Miller-Jones, and he's going to talk to you about website performance testing, meaningful best practices. Steve has worked in the streaming and CDN industry since 2008 and has a strong software project management and web application programming background. As a principal architect for Limelight Networks, he enables Limelight to understand how its services perform from the outside in and from the inside out. Using real user measurement data alongside synthetic and system-wide monitoring services, he leads development of products that ensure consistent, high-quality content delivery worldwide. Prior to joining Limelight, he was COO of Global Mix, which won the Streaming Media Best CDN in Europe Award in 2009. Steve lives in Brighton, UK, where his young family keeps him very busy and covered in pink things and glitter, but he finds time to cook occasionally, write music, and contribute to thethursdaynightshow.com. Folks, we're really excited to have Steve with us today to present this webcast for you all. As we get the program started here, I'd like to go over just a little housekeeping to help you get the most out of today's webcast. First, you'll want to open your group chat widget if you haven't already done so. This is where we can interact with each other during the event and where you can submit your questions for Steve. We find that our audience usually has a lot of good knowledge to share, so we encourage you all to chat freely during the event. However, if you have questions for Steve, please preface them with a capital letter Q so we know that they're for him and we can make sure we see it from Q&A. You can also open, move, and resize any of the other widgets. Folks, if you have any trouble with the webcast today, please take a look at your help widget. If you continue to have trouble, just post it in the group chat and one of our staff will help you right away. And folks, at this time, it is my pleasure to turn the program over to Steve for his presentation. Hello, Steve.
Hi, Yasmina. Thank you for that great introduction. Good morning, everybody. Good afternoon, or maybe even good evening or late night, depending on where you all are in the world. Thank you for joining our webinar today. Today we're going to look at website testing and specifically looking at website performance testing with a focus on some dynamic content acceleration. And I'll be trying to look at what to measure and understanding what the measurements mean when we get the measurements, looking underneath them to find out what's actually hiding underneath individual measurement points. I'm going to cover how we're addressing some of the issues of delivering dynamic content over the public internet. And I'm going to show you a demo of some of the tools that we use to make comparative tests between different optimizations to show for existing customers and for people who might be interested in using Limelight how we find optimizations that can work for their websites and web applications. I'm also going to be looking at how we get the widest possible view of performance, so how this ties into business KPIs, so that from the webinar you can sort of take away some ideas about how your testing that you're undertaking or going to start undertaking or have been undertaking can lead to some impactful benefits for your business. And I'm going to show you some real-world data examples of how these KPIs actually exist in the real world. So, let me get the slides working, excuse me. What we really see is that, the digital, enhancing a digital experience for your entire audience is pretty vital today. And what we see is that there are many elements involved in delivering a compelling experience for your website and for your application users. The key challenges, I think, are really directly, and the ones that directly impact your performance of websites and apps are sort of making sure that the rate at which users receive data is consistent and high, and that you're able to address all of the different aspects of latency. So this is, the distance that users are away from your infrastructure, the propagation time, the speed of light latency, and also things like how fast your search lookups, your database queries run, how fast you can get data off of your storage disks and into flight, and how long it takes you and your infrastructure to get data from systems into the bit stream. And making sure we're addressing all of these areas of latency is pretty important in understanding the total delivery experience. And of course, we have to have high availability now across any device at all times of day. And I think this really leads into all of the other points on this slide. There are a huge array of devices that we have to support today. And we have to support many versions of browsers or application or environments that make the delivery of a consistent user experience across all of them more complex than it has been before. We have to decide how to deploy the right level and scale of infrastructure and bandwidth to meet peak demand as it's needed, or even determine if peak demand should be catered for by our own infrastructure or your own infrastructure. And thinking about where the audience is, how to scale correctly in the locations where they are. And then actually at the end of it, do we have enough data about all of these things to be able to take any action to understand what's happening, how to improve it, and also how to improve on the increasing demands for personalized content that there are online today. And all of the items that we might need to include in our sites or apps due to product requirements or user and design requirements, and anything that influences how sites and apps work, all add up to the time it takes for a page to load and the time that users have got to wait before they can interact with your content. And so we'll be returning to some of these stats a bit later on and show you some examples of how this data actually plays out in the real world. And of course, the challenge of delivering websites and apps is not really what it used to be. We all know that offline media has moved online, but it's moved into multiple devices that are used at different times of the day. So, for example, we know that the early morning traffic spikes are typically users on mobiles consuming content, and then that consumption trend moves to laptops and PCs during the daytime, and then it moves again onto tablets, TVs, and PCs or laptops in the evening. So we sort of end up with 3 different spikes during a daytime period, whether event-driven or not, where users are consuming the same content and expecting to get the same experience on a number of different devices at different times of the day. And I think this really plays to the fact that user expectations of how well these things work across these different devices at these different times of day does not change just because of the type of device people are using. The expectations of the user stay the same. And if anything, they've become more challenging for us as application development and delivery specialists to deliver, because users expect a near instant response time on all devices. And even if we get to 300 milliseconds, the user's expecting that something's about to happen. They think the device is working. But as we get up towards a second, people start to move away. And all you have to do is think about your own experiences of waiting for an image to load of a product you're looking at, and if it doesn't load quickly, you go away and you start looking for it somewhere else. So we have to get the experience the users want every time on every device, and this has become more and more challenging as time has moved on. So this brings us sort of to the question of what is performance and what should we measure and how should we measure it. And a recurring theme I'll come back to is thinking about things in a sort of cyclical way. And we've got to remember, we can't measure what we can't observe. and we can't improve what we don't measure. So if you're not capturing data about lots of things, then we can't hope to measure it and understand what it means and make decisions based on that data. And so I think this is a pretty cyclical point which leads into all of the methodological statements about how we perform testing and how we choose what's to optimize. And if we're choosing to optimize the things that are actually important to the end users or just to our business KPIs. And then are we also measuring what we're optimizing? So I think these are the key cyclical pieces of the performance testing discussion that need to be considered. So I'm going to go to a poll. So we've got 3 polls for you throughout the talk this morning. And so the first poll is really a question about what drives your current testing program. So I'm interested if you have a program or not, if you're doing it to determine how you maintain your performance, if you're trying to look at it from does a new feature we're going to release during our continuous release process or regular release process, does it impact performance? Are you trying to use testing to understand if there even is a problem you need to address? So let's have a look. I'll leave that open for about another 5 seconds or so. And I'll close that in 3, 2, 1. And then let's have a look at what you all think. Okay. Sorry, I had to press the right button. Excuse me. There we go. So 20% of you don't have a testing program, so you're probably listening to me to get an idea of how to go about testing and what to do. The largest number of you are trying to use testing to understand if you've got a performance problem. So this is probably deltas between trends over time and specific things you're looking at. And then there's a number of you looking at maintaining performance on an ongoing basis and looking at ensuring changes don't impact performance. So thank you very much for the poll. There'll be a couple more later as we go on. And so the question of what is performance. So is performance just speed? Are we just testing speed of things? So performance does equal speed, but it also is more than that. And how fast things work is definitely is part of performance in almost every layer of the website or application architecture that we have. And speed is really a function of getting work done. So performing some kind of search, performing some kind of database lookup, presenting images, fulfilling an order, delivering a video, or reading and presenting personalized data of some kind in a dynamic environment. So what we're really trying to improve with performance is making the websites and applications get their work done efficiently and effectively. So the speed of performance is really the speed of getting this work done. And so what are the major impacts here, apart from the obvious things in the speed box there? They're things like scale. Scale is a hugely significant part of performance. And you need to think about whether or not you have to scale your infrastructure to meet your audience peak size, or if you can use some other systems of caching or delivery to do that for you. And if you're able to, are you able to measure how well that's performing for you at peak? Do you have, if you offload the delivery of some of your content, dynamic or otherwise, to a third party, do you have single points of failure that will give you a huge traffic spike when you are either successful in creating a traffic spike or when one happens that you aren't expecting? Do you have parts of your web page which are going to slow down the whole piece? So thinking about scale is important, the reach, availability, techniques for cacheability and looking out for and understanding runtime errors, and looking at how you interconnect with ISPs and connectivity networks and to get to where your end users really are. Think about mobile networks. The latency in mobile networks is in the carrier network, and you need to be as close to them as you can get. How do you go about achieving that? And all of these things tie into performance just as much as how fast things are once you've got connections and once you're able to deliver the content. And so this really leads us to a question of thinking about how should we measure things. What should we measure, and how should we measure it? And I think this comes back to the cyclical question of measuring things you can see and being able to see all of the data. And so I think there are sort of these 5 areas that we have in any online system which needs to be measured. So, it's the two basic questions. Are you actually online with your basic system health checks? Making sure that you've got enough data to understand what it means when you're online. So you might be online, but things might not be working very well. So your health checks sufficiently deep enough to tell you that you're online and everything's working. Are you able to track what's happening, catch the errors and diagnose and create profiles of what people do and profiles of errors or anomalies over time so that you can profile events and then determine what to do about them and if they are in fact problematic. And this is all part of determining if you've got a performance problem, and if you have, baselining it and measuring it over time so you can identify it continuing to happen. And then looking at how fast things are, measuring the work being done like I was talking about before, looking at lookups, looking at personalized data presentation, looking at how fast things come off of your storage infrastructure. And again, building a model about what's needed to make your web experience, your application experience work well to determine how fast it actually is. And then you're moving into looking at things to optimize and determining if you made it better. And I think at this point, this is where we need to let your users tell you if you made it better. And this is where we get into the arena of user-centric metrics and using them in your testing methodologies so that you have not only information about your back-end systems, but you also have information about how you expect things to work and how things actually are working from an end-user perspective. So I think these sort of fall into these kind of brackets. We've got operational system performance, we've got application logging, and we have usage data, which is really where the sort of testing and website and application testing that we do at Limelight and that we talk with our customers about a lot. This is really the area we're talking about. Is it fast? Is it working? Is it fast? Do we know what to optimize? And were we actually able to make it better once we tried to optimize it? So I'm going to take a brief diversion and just talk quickly about one of the challenges that Limelight's trying to solve. And the question is, how can we solve internet congestion? And why do I ask this question? Well, we've got a basic problem online that we all experience. So, what we're trying to solve for is that we've got any user on any kind of device, anywhere, and they're using whatever protocol they're using to access your content. And in between them and your servers, your content, your origin, the data center that you've chosen to host your infrastructure in your data centers, you've got the public internet, which is essentially a series of networks that are joined together, which may or may not be working efficiently. If we think about the net neutrality arguments that are going on, for example, in the US at the moment, and we think about in Europe and across Asia, we think about interconnections between different countries. The public internet, the pathway in between your infrastructure, your content, and the users is essentially a black box to you. And there's a sort of element of send and pray when you're sending your content from your servers across it. And you're expecting it to work, but it's essentially out of your control. So one way to approach this is for you to start looking at implementing caching systems or services closer to your end users, which you could do yourself. You could use a CDN such as ourselves or any of the other ones to do. And this gives you, some optimization in the last mile, and you're essentially inserting caching servers near to where your end users are, so that the work your infrastructure is doing is just for the dynamic pieces, and you're offloading anything that doesn't need to be work done by your infrastructure, so it's closer to the end users, and you're able to optimize in the last mile. One of the other things, and the way that Limelight look at this, is that we look to optimize the entire journey, so that not only can you offload static objects into caches near to end users, but you can also improve the way in which dynamic content requests and responses are managed and delivered across the internet, essentially by using a private network to accelerate and optimize the delivery of dynamic content, address the latency in the middle mile that exists, and ensure that the entire delivery path is optimized, including dynamic and static content, including posts, so search lookups, and so on. And finally, the other area which I think is important, which we need to consider when we're talking about performance testing, is how does the browser behave? What are users doing once they've requested a page? What's happening for them? And are we able to decrease the time the users have to wait before the page can be 100% visible. So the graph on the screen here is from a tool called Webpage Test, and this graph is showing the speed index of a page. The blue line shows a page that is unoptimized for front-end acceleration or browser-level acceleration, and the red line shows how quickly the whole page is visible to the user. So the red line reaches 100% faster than the blue line by some considerable amount. And essentially this starts to show us that it is possible to improve the user experience, but we also need to think about how we're going to measure that and what we're going to do in order to show that we are making any kind of impact on this at all. So that's sort of a line-up of what the problem is from the market perspective. One of the particular problems that Limelight are trying to solve, and that we have a particular solution for solving, and also identifying that while we can solve things like object delivery speed, we're also trying to make sure that the user's experience is managed for, and that the users aren't waiting for something to happen, and can we even tell if that's happening, and what happens if they have to wait for another 1 or 2 seconds or 3 seconds, and is there any data we've got that can show us that these things are important and should be considered in our KPIs. Okay, so I'm going to show you around a system that we use to measure performance improvement. And what I'm going to try and do is show you some results we have from a trial, and showing you how we use third-party tools, which are available to anybody, to measure performance, and what the results, type of results you get are, and some of what they mean. And what I'm going to try and impart here is not looking at the difference we can get in the results, but I'm looking to show you how the selection of the tool set itself leads you to being able to discover certain things. And also, we then need to think about how to analyze the results and drill down into individual aspects of a test so that it's meaningful for you and offers you the opportunity to generate knowledge from your own testing. So I'm going to just set up a screen share. So bear with me for 1 second while I get this working. Okay, so I think you're seeing my screen, and I'm pretty sure that that's working. So what we're seeing here is a tool that Limelight have built internally, which shows results of tests that we carry out. And I'm showing you an overview page for a website that we tested in a certain period of time. And it shows some high-level results. And I'm able to show you an overview for the speed metric index for web page test. What does that mean? Well, what this system has done is we've built against the publicly available web page test APIs to enable a scheduled set of tests to run across different places in the world at different times. And then we're able to pull the data back from the APIs and compare data points together so that we can see not only what the improvement is, but what the original state was like. So we've got blue is the current state and red is the improved state. So we've got a graph that shows us, performance over time. So, and where this performance is coming from is from all of these different web page test agents that we have deployed, and these tests are run simultaneously so that we can do a comparative test. So you yourselves can do this as well by using the publicly available web page test tools and the APIs they offer you. So you could set up, if you needed to, your own performance testing to show how things work from a browser perspective. And web page test offers you quite a lot of detailed information into individual tests. So let's have a look, for example, at these two. So let's have a look at this current state. And what this is going to show us is it's going to show us a waterfall of page that's loaded during the test. And so we get a number of metrics about load times, first byte times. We get start render time, visually complete time. We get a speed index. And we also have some high-level statistics about requests and time. And what we can see in the waterfall view is how long things like connections, time to first byte, and download times take. And if we click into them, we're able to see time to first byte metrics. And of course, in a dynamic page, time to first byte is pretty important because it's essentially an indicator of how long the infrastructure is taking to do the work that it's being asked to generate the HTML page and return it. And then after the HTML is returned, all of these other objects on the page can then be loaded. So we can see then that the time to first byte there, well, is it much different with the optimized test? And what we're able to see in an optimized test is that the time to first byte is in fact, reasonably similar, 545 milliseconds versus, say, 596. So there is definitely a benefit there. But what we're also then able to see in the waterfall chart is how the benefit of optimization really takes away the content download time and the time to first byte and the connection times. And we get down from, something like a 13-second down to a 4-second response time. So what we're then able to do is start analyzing the different parts of these tests if we want to. We can drill into different pieces that have got SSL negotiations. How's our TLS optimization doing? How's TLS optimization on the origin? Are we reusing connections efficiently and effectively? Has this all been done according to best practices? And then one of the other things that web page test offers, of course, if your users that you're trying to present your results to aren't particularly technical, it offers the ability to create a video that shows how the different performance improvements affect the load of the page. So if you've got a user or someone who you need to talk to about your results, and they're not going to be able to look at a waterfall chart and really get in and understand what it means, but you need to make an impression on them, then web page test offers you a great ability to go and demonstrate how all of these things are working. And so what we've been able to do is by using public APIs and by using the web page test infrastructure that we've been able to build, and you could do this against the public infrastructures as well, as build a system which will benchmark web page loading speed against a number of different parameters and be able to compare them across different optimizations and different tests that we choose to run. Okay. So I hope that's shown you, on some levels, that what you're able to do with testing is to, using tools that are available, synthetic tools or real user data tools, is you're able to set up comparisons, and that the kind of comparisons you can set up will start to show you real differences between how optimizations affect the delivery of dynamic and static content. And that by being able to use side-by-side comparisons, you can start to build baselines of performance over time and make comparisons between them to build a state of useful knowledge to share within the company about how performance impacts on your KPIs. So one of the important things to think about is, I suppose, how we would use a methodology and how testing methodologies impact what the benefits of your results are. And I suppose you need to have an outcome that's of interest to your company or the business group you're working with as a result of you bothering to undertake any testing in the first place. So you need a consistent, agreed methodology, which is designed to analyze and showcase specific data that's actually meaningful to your business. And an important aspect of performance testing, I think, is perhaps to look at how it's received within your organization. So, if you're able to publish results of ongoing performance testing and start to generate, a focus on performance overall as part of the culture of a business or the teams that you work in, then, business units or individual groups that make a real difference to the performance website can start seeing the benefit of that across the business, and other business units recognize and understand that the work that's going on is actually making a difference to the KPIs that the business is being held to. Whereas if you're not publishing data, you're also then not able to see how things that negatively impact performance need to be addressed. And so I think the idea of being able to generate this idea across a business that performance is part of the culture is important, and I think that helps with any testing methodology and getting kind of support from within the business on continuing it and looking at its cost benefit, and also being able to pull out and get buy-in to the information that's being produced by the business units that needs to take action on it. And so I think also the methodology then needs to be meaningful, and these are the basic steps you'd follow to have meaningful testing. But the most important thing, I think, is to establish what the business KPIs are that people actually care about, that need to be impacted, or things that don't need to be impacted by testing, and to design a testing methodology around these in order to make testing meaningful. So I'm going to move on and look at some specific types of testing and what they mean and how to review their benefits. But we're going to have a second poll question. So let's have a poll come up. So I'm interested to ask you what tools make up your testing kit. So if you're doing testing, or if you're planning to do testing, are you using just synthetic page testing or object testing? Are you using real user metrics or a combination of those things? Or perhaps you're not using any tools. So this is what this poll is about. Okay, I'm going to leave this up for a few more seconds. And maybe if those of you, who are using tools, maybe there's a discussion in the chat room about which tools you find useful and why they're useful for you. Okay, so let's have a look at what you all think. So it's pretty even spread about what tools there are that people are using, which is interesting. So I think what's interesting is that there are an amount of people using both synthetic testing and real user metrics. So what we're going to show through the next section of the presentation is, what are the data points we can get from synthetic data? How do we look beyond, the surface of any data that we collect? And we're going to round up by looking at the kinds of data we can get from real user measurement, how they map to KPIs, and how you can actually tell if this is actually having an impact on the performance of your website and potentially the revenue that you can earn from it. Okay, so let's talk about simulated usage data. So this is, synthetic testing of any kind. As the name suggests, these would be tests that you'd carry out or conduct by some kind of agent installed somewhere on the internet. And they would be used to simulate various use cases like downloading an object or testing a whole page as it's loaded, and to provide a breakdown, a bit like we saw in the waterfall chart that I showed earlier for the individual objects, how long it takes for the DNS lookups, the connection time, the first byte download, time to last byte, and so on. And synthetic tests provide, obviously, for those of you that know, you obviously know this, those of you who are thinking about how to do this, they provide a great mechanism of describing what performance should be like for real users and to provide this kind of baseline. It's obviously not real user data. And of course, the agents are generally installed in data centers or virtual machines. And of course, your users aren't virtual machines or located in data centers. But the point is that they're able to give you enough data to have a baseline understanding and do some benchmarking that shows you what you should expect performance to be like. And then this should give you the ability to create and track trends over time of what performance should be, so that you can then think about measuring the impact that changes will have before you release them. If you're doing A/B testing, you can measure the difference in performance or the difference in completion rate or the difference in bounce rate that different features could give you, levels of efficiency against back-end versus front-end. And, you're essentially trying to identify trend, focus on outliers and fluctuations in that trend to understand what they mean, and to classify the data that the tests are giving you, group it together, and start analyzing it for meaning. And an important part of synthetic testing can certainly be to simulate the journey you're expecting users to take through your website or through your application in order to understand how long it actually takes them in total to complete the thing you're hoping that they're going to do when they visit your site. Are you hoping they're going to search for and find a document to download? Are you hoping they're going to find a hotel room to book? Are you hoping that they're going to find their bill? Are you hoping that they're going to watch a video? What is it that you're expecting them to do, and how long do you think it should take them to do that as a trend, and does that trend change over time? And this is a really useful piece of synthetic data because it gives you a baseline from which your level of understanding can be built and which you can start to build your KPIs on, and understand if there is actually a problem in this journey. And that can then help inform your product decisions, your use cases about how to improve your site, and the features, functionality mix you should have. The kind of results, the kind of results that we'd expect to get from any kind of synthetic testing is kind of similar to this. This is an example of a Gomez graph. And most synthetic testing tools, so you saw the tool that we built based on web page test, which showed a similar kind of graph. This is a graph from Gomez. Graphs look similar in synthetic tools like Keynote. And they have, aggregated data points that show you average data over time. They might be scatter plots, they might be line graphs, or column graphs of some kind. And you can plot things like standard deviations, but the values that you're getting in the individual data points are pretty typically an average over time. So one of the questions you have to ask when you're beginning to get synthetic data and you're beginning to look into it to see what it means is you have to start getting behind the average. What does the mean actually mean? Is average a good enough measurement for you to use in order to establish your performance baseline and to then improve from it? And can you actually represent the data in a better way? So this is some data that we were able to find when we did some testing. So we were testing a fully static web page, a dynamic web page which had some personalized information in it, and a sort of a product details page. And you can see that we had, some poor performance apparently, and one good sort of performance. But these are on average results. So a question sort of comes to mind is, what is the average made up of? So what we're able to do with averages is then start taking the data apart, and from any synthetic testing tool, you should be able to get access to all of the data points that make up the data sets. And you could start to create yourself a histogram of data using Excel, like we've done here, for example. And then the histogram will describe the data set where your average comes from. And the histogram will typically be used to show you, for a web page or for an object, how long it takes to load and how many of your test results fit into each time bracket. So in this graph, we've got the red lines show what an origin was like, and the blue lines show what the performance was like when Limelight did some optimizations. And we saw a 3% decrease in average, but what we're actually able to see within the data set is something quite different. We're able to see on the very left of the graph, there are more data points in lower time bands. So we were able to move more users into lower time bands. And we're also able to see that the long tail, the right-hand side of the graph, was dramatically different and moved towards the left as well, which indicates that there's a wider set of users getting a lower time for the page to load than against the original. So the minus 3% average doesn't tell you any of the data that's hiding in there. And if we look at a different result, we're also able to see that we got a minus 13% average, but we're able to see that has been the case because of the origin server, or the original server, having a large number of users getting their results in the fifth time band from the left, but we were able to move quite a number of them into lower time bands, but we're not able to impact the average. So the average isn't showing that we're able to improve the distribution, or even that the long tail doesn't change much, which indicates there's two sets of user types, or there's a difference between all of the user groups, which indicates there is some secondary reason. Could it be geography? Could be ISP? Could be browser type that indicates some users are always going to get a slightly worse performance time. And then looking behind the average and where a 22% improvement has come from, we can then see how this is spread out and how the improvement is actually going to be spread across the user base. So in this one, we're able to reduce the long tail significantly and spread the two very tall sets of results into the 6 lower time bands than have existed in the first place. Finally, I want to have a look from a histogram perspective and look at what else is hiding. In a different test we did with a complete homepage, we're able to see that we've got 2 sets of distribution. So an average is never going to show you this. So this is one of the important pieces drilling into all of the data points and capturing as much data as you can from your testing and then being able to analyze it using different tool sets, is this reveals that there's sort of two sets of distribution going on here. So this is likely to be a country which has got a highly populated central area and a lot of the population spread out around that central data, or maybe 2 or 3 big cities with a rural population spread evenly around them. And we're seeing two distinct areas where performance needs to be improved. So this shows that what's behind the averages is the distribution of how the performance is achieved and where you can then start to focus your efforts. How would you change your web page to impact all users so that the users who are perhaps further away from your infrastructure are able to achieve a lower time in the loading of the web page as well. One of the things that's important when we're talking about testing, of course, when we're measuring synthetic testing, is they're not experiencing averages, and they're not experiencing really time to first byte or time to last byte. I mean, if you want to measure time to last byte, what you're really looking at is, when do the lights on my network card stop flashing? That's time to last byte. No one's really looking at that. People are looking at a screen, especially on a mobile phone, for example, waiting for something to happen. So, are we able to impact this at all? And I think one of the tools that I showed earlier in our demonstration was that we've been using to indicate how we can affect this is using web page tests. And I think this is a great synthetic tool that has a lot of flexibility in it. It's open source. It's available with open APIs. Anyone can use it. It's run within Google and created by Pat Meenan. And you're able to put your own timing beacons into your pages to measure them within web page tests. And we've used it a lot to measure the improvement in time to action on web pages with our front-end acceleration optimizations. And I showed you previously this graph that's worth looking at again, which is how fast it's possible to get the visual elements of a page shown to a user so they can start to look around the page while all of the other pieces load in the background. And the red line shows some of the benefits of using front-end optimizations as recorded using web page tests. So it's a great synthetic tool for recording not only what's happening in the delivery of objects, DNS time, connection time, lookups, connection time, time to first byte, time to last byte, but it's also able to record things that are going on in the browser, such as DOM completion, DOM readiness, and actual speed index of how fast the page is presented to people. And none of these measurements are averages either. So you're able to drill into individual data points and get beyond just looking at average data and using averages as the basis for your performance testing. Okay, so a little sort of wrap up of synthetic testing. What we're trying to do, going back to a couple of earlier points, is observe, measure, and optimize things. So, we have to be observing everything that's going on in order to measure it properly. And if we're not measuring things, then we've got no chance of improving them. So we want to use synthetic tools to support the methodology that we've agreed on within our companies and measure performance so that we can get a baseline of performance of different types of objects, of different user journeys, of different page types. Then we need to be aware of what the results are meaning, so getting underneath the data to understand what the data is actually showing us, and comparing results across different types of tests to get a full picture of what the tests are telling us and give us consistent benchmarks. So synthetic testing, it's great to measure time to last byte, but I think what's important is that it's not a useful measurement by itself, and I think it's useful to combine different testing agents and measurement types and measurement methodologies to measure what's actually important to users and build business KPIs that are built around these things. And so I definitely think synthetic testing is part of a method of observation and measurement to create knowledge about what happens when you simulate usage. And I think the kind of KPIs that we drive towards and that we think are important in Limelight are based around three basic things. So first of all, we're trying to make sure that we lower abandonment rates on websites. So, If you're able to lower your abandonment rate or your bounce rate, then you're able to create more opportunities for users to complete whatever transaction it is or whatever action it is your website is designed to deliver. And this opens your opportunity to earning more revenue per visit. Breaking down performance in different pieces to lower these abandonment rates should be a primary focus, I think, of any performance testing methodology, and definitely one of the core parts of KPI analysis for website performance testing. We also then need to think about higher conversion rates. Journeys that users take to complete the transaction or whatever action you're trying to make them take is pretty important, and it leads you towards metrics like potential for conversion versus actual conversion. And obviously what you want is your delta, your difference between potential and actual conversions to be as close as possible. And you want to focus on measurements on ensuring that trend is able to continue and doesn't diverge at all. So, if 30% of your users abandon the shopping trolley before they purchase, you've also got to ask yourself the question, how much of that is down to the performance of the web page and how much of that is down to the product they're trying to buy? And what you want to do is try and eliminate the performance of the website as the reason that people aren't buying. It might be an obvious statement, but using a testing methodology to make sure you spend the right levels of effort establishing if it's the performance issue that's affecting these purchases or not is pretty important and drives other KPIs within the business. And then finally, the third one I think is important is to look at the user experience. We looked at earlier trends in usage, how fast people expect things to work, and the trends of when people are using different types of devices, and the fact that their expectations are the same across all of those times. Personalization with consistency is critical in building trust in your brand, especially where you're creating these more personalized experiences for your users. And you're trying to turn your users into ambassadors for you, so that they continue using your products and services and recommend them to other people. So focusing your testing on ensuring that the user experience is optimized, and metrics like time to wait and speed index are incorporated into your methodology are pretty important, so that you can actually then measure them, optimize them, and act upon them. So I'm going to go to the last poll question we have, which is about this topic, about the KPI topic. So I'm interested in what you guys are actually measuring. Are you measuring page and object measurements? Are you looking at KPIs like bounce rates or page views per session, transaction capability, potential versus actual transactions? All of these things? None of these things. Hopefully this poll gives you a chance to tell us what you're doing, and maybe this will cause some discussion in the chat room too. Okay, I'm going to leave this open for another few seconds. I'll close it in 3, 2, 1, and let's have a look at the results. So the majority of you are looking at time to first byte and time to last byte. So hopefully what we've been talking about today will lead you to consider thinking about other measurements too, and getting underneath those measurements, using them as a definite baseline, and using them as important parts of the methodology, but also stretching out beyond there. Bounce rate and page views per visit or session are getting some importance. Potential versus actual not registering, which is interesting, and none of the above. So maybe the 15% or so of you that aren't doing any of these things, maybe it'd be interesting in the chat room to discuss what it is you are using and see if others are using those too. So let's take a minute to talk about real user data, because the KPIs that we're looking at there and that I've been discussing, part of the way of understanding how you're performing against them is about combining data from real users with data from synthetic testing that we've got. I'm going to show some examples of why I think this is important in a minute, but let's just run through some of the high-level real user metrics or measurement solutions. There are a number of vendors in the marketplace that can offer them to you. You can build them yourselves. Typically, they're made up of some kind of JavaScript object, which is implemented on your pages in a non-render blocking manner, so they don't impact the load of the page, but when the page is being loaded, they beacon back information about the page load. They can also be used to load specific objects that tell you how your infrastructure is operating or how a service provider you're using is operating. They also make use of, some of them can make use of navigation timing APIs that are available in modern browsers that will tell you things like, when was the DOM interactive, when was the DOM ready, when was first paint by the browser done, when was painting complete. And I think the important thing to remember if you're selecting a run vendor is to look at how the methodologies they use are different and are they suited to your purpose. Is there public data available for them? What makes up that data? If they're testing their own objects, how big are they? Are they representative of your content, the objects that are on your pages? The other area of real user metrics I wanted to touch on is, using them to capture actual versus synthetic benchmarking, use them for your A/B testing, use them to line up with your benchmarks of what you expected happening with what is actually taking place on your website, and track these against your expected feature releases that you're or improvements that you're making. Analyze against marketing efforts, because the real user metrics will show you spikes in users arriving at your site if you're successful in creating a marketing event that drives traffic towards you, and then you'll be able to use the real user data against your synthetic trend to determine if, once you had that spike of users, if you were able to successfully deliver your pages against them. And again, tracking what people actually do in your website. So I was talking earlier about looking at what people do, what you think they're going to do, use the real user data to track what they actually do, and then look at how you would change your website if you need to cater for that. Okay. And finally, on real user metrics, look at the user experiences, capture the DOM events, and definitely look to insert your own custom timers into the pages that you're measuring so that you can track the same interaction points across all of the different types of devices that you've been using and that your users use. So we're going to have a look at some data. So I'm just going to share my screen again. So what we're looking at here when this comes up, this is a graph of some real user data that shows where the red horizontal and vertical lines intersect. This shows a page load time of 3 seconds, and the thick red curved line shows the bounce rate. So at a 3-second page load time, real user data shows that for this site in question, there's a 19% bounce rate. So bounce rate is users visiting a website who do not do anything other than visit the first page. So we've got a 3-second load time, we've got a 19% bounce rate. Where we've got a 6-second load time, the bounce rate has increased to 27%. So that's a reasonably significant increase. And so what this data is able to show you is that by focusing on moving the users that are experiencing your page loading in 6 seconds down towards your 3-second mark or below will reduce the amount of users that are leaving before doing anything else on your page. This is a graph taken from real user data which shows how load times impact numbers of sessions for particular pages. So we've got a load time of just over 5 seconds. There are 67,000 sessions. And where we have a load time of 9 seconds, then the sessions has dropped in half to 24,000. So again, real indications of real data showing what we all think is true, but if you have a slowly performing page, then your sessions are going to drop significantly. This is an interesting one which shows how page load time affects orders. So the blue line shows a spike up to 7 seconds page load time, and it shows a significant drop in the numbers of orders placed during that spike. And so this is where we would start to track as a key performance indicator the potential for conversion versus actual conversion based on speed of time it takes to load pages, speed of time it takes to complete an actual journey to purchase something. And this is the kind of data that you'd want to profile and keep track of over time to see it recurring, so you can identify what it is that's happening that both causes that traffic spike to happen and thus impacts on your ability to convert orders on your websites. And then finally, you're also able to use real user data to show single points of failure and whether or not they're in your front end, so in the browser, or whether they're in your back end in your infrastructure. So this big spike here shows that during an increase in users visiting a website, there was essentially a single point of failure in the front end in the browser, a third-party object, which caused the page load time to spike enormously. You can see in the green data that there was no change in the back end time. So using this real user data, it's possible to identify exactly where the impact on the website is coming from, and then you can go and address it with knowledge in hand about where this is happening, so you can start looking in the right place. Okay, so just going back to slides, and just got a couple more left. I think there's two other things really to cover in other considerations about performance and where you want to think about performance testing. So caching strategies. Think about the dynamic content. Is dynamic content truly dynamic? If it can be cached for 5 minutes, then let it be cached. If it can't be cached, then make your origin specify what can and can't be cached. If use your headers and your cookies to reflect the actual cacheability of personalized content, and expect service providers and CDNs to be willing and able to let the origin define what happens and still perform at a very high level for you. Look at content storage because it's a significant area of latency introduction. Consider where the content is relative to your users, and especially mobile users. The latency is all in the mobile network. So if your users then, if they're requesting an object which is sitting in storage somewhere, and not only do they have to traverse the mobile network, they've also then got to traverse either a number of countries or a significant distance from the edge of that network to the storage location. You're going to be introducing latency both in terms of how far data has to travel, and you may also be introducing latency based on the type of storage it is, whether it's on spinning disks, how fast are those disks able to get data into the bit stream. So look for a service provider for storage who can reduce the latency between the user and the content by storing it as close to the eyeball networks as possible, and particularly consider this for mobile, tablet, non-PC users. So we're reaching the end, so I'm just going to have a few conclusion slides. I said this a few times, we can't improve what we can't measure, and we're not measuring. And this is true for the entire system. So best practices for testing are to improve system monitoring, so it's not just a statement of up or down. Create a method, goal-driven method for optimization. Capture data about what systems do, categorize it, add to samples over time so that you can really build a picture of what's going on and understand it, and share that within your business so that you can understand how the different business units impact it, that they get a picture of performance over time, and then you're able to share easily and understand what the performance tests you implement are actually revealing. I think it's all about measuring work getting done across your system from end to end and observing the end user experiences in line with that to make sure that they're aligned. I think you should be looking at what your differentiation is in the marketplace and making sure that any performance you have is orientated around that differentiation. If you measure the performance of your expected user journeys, look at what they then actually do and how long this actually takes, you can optimize for how your site, your app is actually used. And this will provide you with insight and knowledge that measuring individual pages and objects won't provide on its own. So in conclusion, use synthetic testing, I think, to optimize features prior to release. Monitor your trends and availability over time. Benchmark your systems, benchmark your competitors, benchmark the features that you're trying to release. Use RUM to understand what users actually do and compare this against your expectations, and help reveal areas for optimization and focus on things that will really improve your business KPIs. And finally, I'd like to say, let us do some work for you. We're offering complimentary performance tests currently using the tool that I showed you earlier. It's non-disruptive. We're able to make some assessment of the site now and what optimizations could do for you, and provide you with a detailed summary report. And there's some details on who to contact there. And then finally, we have, I think, available in the collateral in this webinar, there's a white paper, a step-by-step guide to high-performance websites and web applications for you. I hope you've enjoyed the talk this morning. That brings me to the end of the talk, and I'm going to go and look at some questions. So, I'm just trying to get to the questions. Okay, so there's a question about real user metrics with JavaScript from Muzel. Do you just rely on the window performance object? How do you go about measuring performance in older browsers? This is a good question. So modern browsers will give you access to the API, navigation timing API, which you can use. In older browsers, you're going to have to do something using a JavaScript library, which you will load in an iframe that's hidden in a non-blocking fashion, and use techniques such as those described by boomerang.js, which will then enable you to gather information about what's happened and beacon that data back towards your data capturing infrastructure. You won't be able to get as much data, so you won't be able to capture things like DOM Interactive, for example, as you can gather from your navigation timing APIs, but you'll be able to gather data, and you'll also be able to use the iframes in older browsers to load a specific object and test that as well, so you can get indications from real users about how a specific object is loaded, and that gives you the ability to determine how a particular object for your website is loading for older browsers. Using synthetic monitoring, there's another question from Peter. Should we measure with or without third-party content? I think, as I think one of the graphs I showed just now shows, third-party content is pretty important and can be very important to sites. And if it's going to impact you, you probably need to know about it. So I would say that you should have a focus on any third-party object which is important to you. Maybe you should be benchmarking over time how it's performing within your website. And are there different ways to implement it? Do they have different methods of implementation you could use? Or could you change how and where you've implemented those pieces? So I think third-party content is definitely worth measuring to create a benchmark of how you think it's impacting your sites over time. And you should be looking, if they change it, if they introduce a new version, is that going to impact your site? And if you can benchmark with volume, would you be able to see that a third-party object is going to give you a problem if you have a unplanned or a planned traffic spike? I think that'd be quite an important thing to measure going forwards. Do I think web page test will be accepted as a measurement tool by an enterprise? Is another question from Peter. I think that's an interesting question, because I think what is important to be accepted by an enterprise is what KPIs are you measuring, and how the data would be presented. So is the enterprise going to have an issue with determining which tools you use to gather that data and to measure against the KPI? Or is the enterprise going to be more interested in which KPIs you're measuring, that you can then go and choose the right tool to measure them with? So I think maybe that's the way to look at that question. Web page test is simply a synthetic tool you don't have to pay for, which can help you to measure a number of pieces. You can use other tools to measure those pieces as well. So if you have a need to use a commercial service, or something like a Keynote or a Gomez, they're offering you very similar data points, but in a completely different way. And web page test is offering you more information about how browsers behave with your content. And so I think it firmly depends on what your business wants to track as a KPI and what you're able to drive as a set of key KPIs that you're measuring your performance against. Let's have a look. There's a question from Paul about how single-page apps using, he's got an example, ember.js, change how we go about looking at web app performance. I think if you're looking at using common libraries, I think you should look at how that library performs for you. And if there are other ways of going about achieving that, you might have to obviously choose to make a significant development effort to replace it or to do something else. So the testing that you can do with it could indicate whether or not that investment would be worth making. So you could use testing to identify if it's not good enough, or if there are pieces of it that you aren't using, or you're only using a very small piece of it, and you need to invest in a development effort. I think the testing could show you how you would make a business case for changing what it is you're using. Okay, I don't know if we have time for any more. I realise we're running 5 minutes over.
Steve, if you'd like to keep going, that's fine.
Okay. What else have we got? Why under speed? This is a question from Peter Laurent again, or Laurent again. Why under speed do you not mention first paint? I think first paint can be really important. An interesting thing about first paint is it may not be, it doesn't necessarily indicate what's being painted. So I think what's interesting in the speed index is it's showing you when and the progression of visually complete on a page. So first paint will show you when the browser is starting to paint its first object, I think. So I think the speed index is a more holistic measurement of what the user is actually able to see and how fast the percentage of page complete is achieved, gives a better indication of how the user is experiencing the site. Time to first paint is probably a useful metric to use alongside it, and I'm not discounting its benefit in any way. I highlighted page speed index because I think it shows the visual completeness of a page quite well. It's designed to show that. And that gives you, if you think about what's happening on a mobile or a tablet or a laptop, you've got different screen sizes, you've got different types of user interaction. You can think about yourself stabbing the mobile phone screen while you're waiting for something to happen. If it's visually complete, then you've got time where you're looking and your brain's computing and you can move around on the page. So I think speed index gives a wider view of the performance. I think you should probably use it in line with paint as well, first paint. And if that then becomes, if you're able to get into that level of detail with your performance testing, then I think you're on the path to making sure all aspects of the page are really well optimized. Okay, I think there was one other question about from Peter. What do we consider to be important business KPIs related to performance? I think I pointed out what I think the 3 key ones are. Excuse me. So abandonment rate, the ability to drive higher conversion rates, potential versus actual, and also to look towards consistent and better user experience to drive brand loyalty. I think those are your 3, the roots of your 3 KPIs. I think individual pieces would come off them. So if you think back to the question about time to first paint versus time to speed index, better user experience is a key KPI. It might have individual pieces underneath it, depending on what your use cases are that would drive. But I think those are the 3 key ones. And I think the data that I was able to show that's gathered from real user systems also shows that this bounce rate, the views per session, and the likelihood of conversion based on the time it takes to load a whole page. I think those show clearly that these are real data points that really impact the success of websites and apps online. Okay, I think we're going to leave it there. I think I've answered all of the ones that came through from the floor. So thank you all for your input. And I'm going to hand back to Yasmina.
Excellent. Thank you so much, Steve, for giving a really great presentation today and for sharing all your knowledge and expertise with us. Folks that attended our webcast today, we thank you for attending and hope you've benefited from it. And as we close out, we'd like to say a very big thank you to Limelight for sponsoring the webcast today and let you know Limelight Networks is a global leader in digital content delivery, empowering customers to better engage with their digital audiences by enabling them to manage and deliver their stories on any device anywhere in the world. Limelight's award-winning Orchestrate platform includes an integrated suite of content delivery technology and services that helps organizations deliver exceptional multi-screen experiences, improve brand awareness, drive revenue, and enhance customer relationships, all while reducing costs. Thank you again, Limelight. Folks, this will conclude today's webcast. Goodbye, everybody.